Hey guys, welcome to week 4 of BFC 3540, and we'll be looking at the VBA task for week 4 in this video. Now, like I've mentioned in previous weeks, this is sort of really reaching the end of the VBA tasks. So in this week, basically, if you've done the previous weeks properly and you understand what you've done and you've coded it up correctly, this week will actually be very, very easy because all of that code applies to what we're doing this week. Now, next week is a little bit different, but basically the first 4 weeks is really trying to build you up to a level where you can work with variance covariance matrices and sort of write code that will give you the variance covariance matrix. So in this video, what I'm going to do is, rather than go through the code bit by bit and in detail, I'm really going to try and show you how you can expand the code that you've written previously to work with this. And what else I'm going to do as well is try to really drive home the main points that you need to look out for this week. Now, if your sheet says that there are errors in this video and don't copy the code verbatim, blah, 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 don't worry about that. There are no errors in this video. That message, if it's still there when you read it, I'll try and change it. But if it's still there when you watch this video, then don't worry about it. Okay, so first of all, if we look at the first sheet on variance covariance matrices, you can see that what you need to do is first of all calculate the mean return for each of these stocks and output it in these cells here for subroutine and output it in these cells here for function. Now you should know how to write an average code for both function and subroutines, but if you don't, we'll go through it right now. Okay, so we'll go through the functions first because I like to start with functions. I feel that it's an easier sort of way to get an idea for the code. Functions are usually shorter than subroutines. Now, there's actually 2 ways that you can approach this. You can write a function which takes this entire matrix as an input and then outputs the averages in this sort of entire row as in general, as a block. Or the other way you can do it is you can just write a function that calculates the average of one column and then use that function 6 times to get the individual mean returns. I prefer to do it the second way for functions, but for subroutines it's actually easier to do it the first way. So I'll do it the second way for functions, and then when we go back and revisit subroutines, we'll do it the first way. Okay, so let's get started. To create a function, you want to create a new module. And let's call this function mean returns. Now you're going to take one input, and that input is going to be the range of cells for which you want to calculate the average. So let's call that input INP. Now you should be familiar with the code to calculate the average of a column. We've done that in VBA task for week 2. So how about we go back to the VBA task for week 2 and simply copy over the code. Okay, so I've gone and copied over the code. I just realized that I made a mistake in that I wrote sub. That should actually say function, so make sure you write that correctly, but I've changed that. Now you should be familiar with how this code works by now. So it includes everything that you know. So you know rows.count, you'll know for loops, you'll know how to define variables, you know why the number of rows is an integer, and you should know why the total is a double. And this is how you calculate mean returns, or just averages in general. So we'll apply this code and try and see if we can correctly calculate the average of these cells here. So to call the function, we type equals mean returns and then open brackets. Now the input is a range, so that input for the first one will just be the mean returns of FMG, and hit enter. And all you have to do now is drag across, and it should completely find continue to find the mean returns of all of these 5 remaining stocks. So now that you have the mean returns, we'll try and do this using a subroutine. Now remember how I said that the function contains basically the guts of a subroutine, and a subroutine is basically just taking the inputs and then putting it into the function and so on and so forth. Well, today that's what we're going to do to try and translate this function into a subroutine. But now before we do that, I want to really point out that for the subroutine, it's much easier, unless you want to write this 6 times, to use a for loop to loop through each of these stocks instead. So how about we go and create a subroutine? We'll talk about how we'll be able to do that. So go back to the sheet Varkov matrix, and we'll call this sub, how about we call this sub mean return 2. Okay, now the subroutine basically has three parts. First of all, we need to input stuff, we need to calculate stuff, and then we need to output stuff. Now, you can actually do this all in one, but there's two ways that you can do this. You can actually do this separately, or you can do this all in one. Now, I'm going to show you how to do this all in one because I believe that that's the better way to code it. So basically what we've done is, if you think about it, the function calculates the average for each individual stock. And what we've done is just run that function 6 times. So if you're doing something iteratively again and again and again, it means that you're using a for loop. So the best place to start is to use a for loop to loop across each of these individual stocks. Now we have 6 stocks, so we know we're going to have to do it 6 times. Okay, and we've used J here, and I've done that for a very specific reason, because when I go and copy the code from the function over, I know that that code uses I inside its loop. So we want to use J here to use a different variable. Now let's go back to the function and look at the guts of what we're really doing. So if we go back to the function here, we can see that basically the guts of what we're doing is this stuff here. So how about we copy this over like we have done before. So if you're not familiar with this, watch video 1b, it'll really help you understand. But for now, let's just copy this code over to the subroutine. And we'll put this inside the for loop. Okay, so here we know that the number of rows and stuff like that isn't going to change, right? It's always going to be 10. So how about we move this line of code outside of the for loop, because that's sort of a constant, right? It doesn't depend on which stock we're working with. So we'll put that outside of the for loop up here. And we'll sort of get the indentation correct. Let's do that. Okay, so it's a bit better indented. Now, instead of having I and P, what we're going to have is, let's see if we've named this range. Yeah, we've named this range returns. Okay, so this is really convenient because we can use the name returns to refer to this range. And the way we do that is using range returns. Okay. So instead of using I and P, we want to use this code right here. So wherever you see I and P, you want to replace that with range returns. So again here. Okay, now let's see what we're doing. So this is going to put the number 10 into no rows, okay? And we're going to loop through each of the cells, and each time we're going to define total as double. That can go out too, because you don't need to define this every single time. You only need to define it once. Okay, let me clean this up. Okay, now let's see what else we're doing here. So each time we're looping through each stock, we're going to calculate its total, and then we're going to calculate mean returns is equal total divided by a number of rows, okay? So that's the code for doing the calculation. Now, we need some way of putting that mean returns into this cell right here. So let's see if we've named this. And yeah, we've named this to be mean, so that makes it really easy for us as well. So in order to output to there, all we need to do is go range means dot cells. Now let's talk about the index here. So how are we going to refer to this cell right here? Notice that we're staying within the same row. So the row is always going to stay the same, and what we're changing is we're changing the columns. And that makes sense, right? We're not inside the I loop anymore, so we don't really have I. We only have J, and J refers to the stock we're on, and the stock is given by the columns. So we want a constant row, and we want changing columns given by J, okay? And that is going to equal mean returns. Okay, so we should define mean returns up here as well. Okay, now let's see what else we have to do. The only other thing we have to change is change this 1 to a J, because notice that now we're no longer working with one stock, but we want to loop through the stock. So the J will give us the column, and that will change as we're looping through. Okay, so the last thing that we actually want to do is notice how we're using total here. And what the total does is basically aggregates the returns for each individual stock. Every time we move to a new stock, so every time we loop through the J, we want the total to reset back to 0. So how about after we've calculated the mean returns and output it, we set the total back to 0 for the next loop to go through. Okay, so how about we run the code and we see whether we get the same results as the function. And running the code, we clearly see that we get the same results as the function, so hopefully the code is correct. Now, if we run this should, in theory, work. So let's give it a go and see if it correctly calculates the the means and whether they're the same as what we get for function. And there we go. And we get the same results as what we do for the function, so we know the code is correct. And now we can move on. So to calculate the excess returns matrix, it's actually very, very easy. All you have to do is you have to take the value here and you subtract the mean in order to get the value here. So it's basically just these values in this matrix right here minus the value of the means. So it's very easy to do using either functions or subroutines. So how about we start by doing it with functions, and then we'll go over and do it with subroutines. So when you're writing the function for this code, it's actually easier to do it basically as a whole matrix rather than doing it one by one. So what I mean is, so you're doing it more like what we did with the subroutine instead. So let's write a function and we'll call it excess returns. Okay, easy enough. Now what we're going to do from here is we know that we need two for loops. We need to loop through the rows and we need to loop through the columns. So how about we go for j is equal to 1 to 6, because we know that we have 6 stocks. Okay, I realize that maybe we shouldn't do it this way, but instead, rather than writing 6, we want to make the code a bit more general so we can apply it also to matrices of other sizes. So what we're going to do is we're going to count the number of columns and rows in the first input. Okay, so rather than going to 6, all we have to do is go to no columns, because the number of columns is the number of stocks that we have. Yeah, we have 6 columns here referring to 6 stocks. And of course, now we're going to need the next I for the loop. So it's always good to start with the syntax, and now clean it up a little bit and we'll put the code in here. Okay, so what's the code going to do? All the code needs to do is take the relevant cell, which is given by input 1 dot cells ij, right? And all you have to do is take the input 1 dot cells ij and subtract the mean return. Now, how do we get the mean return? So we get the mean return by okay, so how do we get the mean return? We get the mean return by referencing these cells here, but how exactly we go, or actually I should say these green cells here. It really doesn't matter which cells you reference, because basically it's going to be input into the function as input 2 anyway. But let's imagine that it's the green ones. So essentially what you have to do is these are the same for each stock. So the rows doesn't change and the columns change. So in effect, what you want is you want to subtract this from this, but you don't move down the row. So as you move down the row, you still stay the same in this. Okay, so we're going to need somewhere to put this output. So how about we define a matrix which is going to allow us to output to. Okay, so when we define the matrix, we resize it to no rows minus 1, no cols minus 1. Matrices start from 0, so you should be familiar with why that is the case. Okay, so here we'll modify the code a little bit. And you should also know why we use I minus 1, j minus 1 as well. It should be apparent for the same reason as that. Matrices start counting from 0. Okay, so we're going to take the input cells here and we're going to minus output, the second input, which is the means. So inp2 dot cells. And now remember that I refers to the rows, and the rows we want to stay the same. So that's going to be a 1, comma. The columns we want to change as we loop through the columns. So that's going to be j, right? Okay, now all we need to do at the end is we're going to have to output our out matrix back to Excel. So we do that by assigning it to the name of the function. Remember that you don't need to have any sort of special code in there. You don't need to have code that will... So remember that you don't need to have any special code in there. You don't need to have indices or anything like that. Just excess returns is equal to out matrix with brackets, and it'll output the array back into Excel. So the way we do this now is we want to highlight this entire range of cells, and we do equals excess returns. And now we're going to select our first input, which is this, comma. Our second input, which is this, you can also select the blue cells. It really doesn't matter. You want to close your brackets. Now, instead of pressing enter, you want to hold Control Shift and then press enter. And with all luck, you should get the excess returns matrix. Now we're going to do this using subroutines. I want to do this week's in a lot of detail because this is the capstone, okay? So if you understand this well, it'll make sense when you go back and look at the materials that you looked at earlier on in the week. So to do this using a subroutine, it's really easy because remember how I said that you can construct a subroutine from a function? It's basically the same thing here. So how about we copy this entire code and put it into a subroutine? So we go back to the Varkov matrix sheet right here. And what we're going to do is rather than creating a function, we're going to create a subroutine. So let's call that subroutines excess returns 2. Okay, so we've created a sub called sub excess returns 2. I'm going to paste everything in there. So now that we've pasted everything in there, I'll show you what we do to modify this to make it work with the subroutine. So I'll give it some space so I'm not covering the code. Okay, so let's look at this here. Now, we want no columns and no rows. We need that, right? But you no longer have input 1 and input 2. Now you have to remember that input 1 is given by the set of cells here that is given the name returns, okay? So anywhere where you see input 1, you want to change that to range returns. And that will tell the subroutine to go and look in the set of cells which is named returns. So we're going to need that there. We're going to need that here. And we're going to need that here, right? Now remember that this basically is what we were inputting into the function as input 1. So instead of referring to input 1, all we're doing is referring to it as range returns, okay? And wherever you see input 2, you're now referring to that as means, okay? So rather than referring to as input 2 as we did with the functions, the subroutine will go into the sheet and look for the cells that's entitled means. And you see that the only place where you see that is right here. So that's going to be range means, okay? Now the logic of the code is still exactly the same, but you're just going to have to make those changes in order for it to reference the right things, right? And you look for the right things. There's no input 1 and input 2 here. It's working directly from the sheet because it's a subroutine. Okay, this can stay the same because the out matrix is basically the same thing. But rather than outputting the out matrix to basically back to what was originally the function name, excess returns, we want to output the out matrix into here. And to output the matrix into here, we need to use a for loop, okay? Now notice that this is called excess. Okay, so we're going to have a for loop that's, again, going to run from j is equal to 1 to no columns, and I is equal to 1 to no rows. Actually, now that I think about it, there's a much smarter way to do this. You don't actually need to output it that way, and that's because rather than outputting it to matrix, you can actually output it directly to this excess thing here. So instead of having this code for an output matrix, how about we just delete all that? And what we do is we output directly to this excess range right here. So rather than having out matrix, whatever, all you have to do is range excess, because that's the name of the range given up here, see? And dot cells I comma j. Now remember that it's I comma j because this is a range, not a matrix, and range start counting from 1. So all we're doing is we're taking the relevant cell and returns, we're subtracting the mean, and that's going to go into excess. So let's run the code and see if this gives us the right answer in these cells here. And as you can see, it should be the same as what you get using functions. So you see, when you're coding, you have to be smart. There's no point being very good at coding, but not knowing how to think well. That's really, really important that you're able to think and solve your way out of problems. There's no point in rote learning things and thinking, okay, I need another for loop for this, I need another if statement for that, or whatever the case may be. if you are doing something that's long and that isn't efficient, then it's not as good as doing something that is efficient, okay? So you can see that rather than solving this with 2 for loops, we've solved both the issue of outputs and inputs in 1 for loop, and that makes the code much more efficient. It means that it will run faster. It means that you get more points than someone who writes code inefficiently. Okay, now we're going to move on to transposing matrices. Now, I'm not going to do this in full because we've done a function for transposing in week 3. I have my week 3 spreadsheet open right here. So if I go to that particular module, this is matrix multiplication, which we don't need yet. So it's going to be this one, module 2. You can see that you have a transposition algorithm here, which you can just copy across and use. So how about we copy this across? So we just copy this exactly from the previous week, and we're going to, we'll create a new module for this because I think the other module is getting quite full. And we'll paste it into here, okay? So this is function transmatrix, and we've pasted it into week 4. Now the only difference is, remember that when we're transposing here, we have to divide by the number of weeks. If you don't understand why this is the case, refer to the lecture slides and or watch the lecture, and it'll become very apparent. But basically when you're calculating the excess returns matrix, it's not just the transpose multiplied by itself. It is the transpose divided by the number of observations per stock, I guess, multiplied by itself. So you have to divide by 10. Now let's look at this function and see where we'd have to divide by 10. So basically you can see here in this line right here, this is sort of the line where the meat, the bulk of the stuff happens. You can see that it's the output array j minus 1 I minus 1 is equal to the input ij. Now rather than having it equal to just the input ij, we want to have it equal to the input ij divided by 10. So basically each of the cells in here will be divided by 10, okay? Now I'm not going to do the subroutine for this, you can do that, and I'll demonstrate that the function works by testing it here. And equals transmatrix. And all we have to do is put this one here in as input, Control Shift Enter, and you can see that you've gotten the output matrix and it's been divided by the number of weeks, which is 10. Okay, so now moving along to the final task. In order to calculate the variance covariance matrix, you have to take the transpose matrix and you multiply that by the original matrix, okay? So we've already written matrix multiplication code in the previous weeks. How about we go back to the week 3 module and we copy this matrix mult algorithm across, and we'll see if it works. Now notice that there's a couple of issues here. The first thing is we've defined the output as an integer because in the previous week, basically we've only worked with integer numbers, but here we're actually multiplying with decimals. So we'll have to change this and temp, the variable where we're storing the variables of the matrix multiplication, into double types. And now this code should work. So if you don't know how this code and the previous algorithm worked, I suggest going back to last week's video where I go through that in detail. So we'll go here, we'll highlight it, go equals, matrix mult, and it should be this matrix here, comma, this matrix here. Okay, and we have to do Control Shift Enter, and hopefully this is the correct variance covariance matrix. I don't know if it is or it isn't, but hopefully it's correct. Okay, so how about we move on? Okay, so how about we move on to the next sheet on portfolios.